Question 11a. Find the inverse of the matrix A, where A is equal to, this is the matrix, element in the first row 6, 11, second row 1, 2. Hence, solve the matrix equation AS equal to B, where S is the column matrix with entries SY, and B the column matrix with entry 29, 5. Solution. The given matrix is a 2 by 2 matrix. To get the inverse of a 2 by 2 matrix, let us assume the general 2 by 2 matrix. The inverse, denoted by A to the power of minus 1, that is the inverse of matrix A, is equal to 1 over determinant. Determinant of this matrix is difference of the product between the two diagonals. You start with the main diagonal, the product is AD. The second diagonal, the product is BC. The difference between the two products gives determinant. So 1 over determinant times this matrix. For this matrix, you interchange the position of the element in the leading diagonal from AD to TA, and the second diagonal you negate it, that is, you use minus 1 to multiply it. This simple rule is used to find the inverse of all 2 by 2 matrices that are invertible. So for this matrix, the inverse becomes 1 over, so A here is 6 times D is 2 minus that is BC, that is 11 times 1. In this form, you interchange the position of 6, 2 to 2, 6, and you negate this diagonal. It becomes minus 11 minus 1. Here is 12 minus 11, that is 1 over 1 times this matrix, and you have this as the inverse of matrix A. To solve the matrix equation AS equal to B means find S. Let us use the inverse method. By the inverse method, the solution is this. For you to get S, multiply through by the inverse of A. That gives S equal to A inverse times B. This is matrix S, this is the inverse, and this is matrix B. To multiply, you take this row to multiply this column, corresponding element to corresponding element, and you add. So you have 2 times 29 plus minus 11 times 5. After that, you take the second row to multiply the only column, corresponding element to corresponding element, and you add minus 1 times 29 plus 6 times 5. That simplifies to this, and you have this. By equality of matrices, you have it that S is equal to 3 and Y is equal to 1. You can visit my teachings on matrix and determinant in my YouTube channel for more details on matrices and determinants. Question 11b. the first and last terms of an arithmetic progression AP are 5 and 89 respectively. If the sum of the AP is 611, find the figure 1 number of terms in the AP. Figure 2 common difference. Solution: for the sum of terms of an AP, we have two formulas. One contains first term and common difference. The other is first term and last term. Since in this question the first and last terms are provided, we use the sum of terms formula containing first and last term. From the question, you are asked to find n, the number of terms, and the sum of n terms is 611. N is unknown. The first term is 5, last term is 89. You replace all of these in this formula, you have this result. Multiply through by 2 to clear fraction. At the same time, you add the two terms in the bracket and you have 94. Divide through by 94 or divide both sides by 94 to get n. So n is equal to 611 times 2 divided by 94. That simplifies to 611 over 47, and that is 13. Therefore, number of terms in that AP are 13. Roman figure 2, for the common difference, you can use the last term formula. The last term is also the same as the nth term. You have it in this form. The last term is 89 equal to first term 5 plus bracket open number of terms 13 minus 1 bracket close times common difference. Transfer 5 to the left hand side, you have this result equal to 13 minus 1, you have 12d. If you subtract, you have this result. To get d, divide both sides by 12 and d is equal to 84 over 12, and that is 7. Therefore, common difference is 7.